Until recently, all private cellular deployments, including with Celona, required a 3GPP 5G core for IP addressing, routing, and SIM and access point management. Now, with Celona AerFlex, you can have private cellular coverage without the need for a physical 3GPP 5G core, which for Celona is known as the Celona Edge. Celona AerFlex moves the critical IP addressing and routing functions from the Celona Edge into the access point itself, and moves the rest of the management functions into the cloud. In this topology, I have a cellular router with a public provider SIM. This represents the enterprise network. The Celona access point is connected to this router. Also connected to this router is this laptop, which has an IP address of 172.123.0.163. The laptop has USB connections to a Zebra ET45 tablet and Zebra TC78 handheld scanner for screencasting. Let's validate our first device, the Zebra TC78. Let's verify the SIM ICC ID. Let's verify the IP address. Note that our second device, the Zebra ET45 tablet, is attached to the same Celona access point, yet has a different IP address domain. The Celona device profile allows for different groups of devices to be treated differently in terms of IP address sourcing, internal to Celona or external to your corporate DHCP server, VLAN routing, and application quality of service via Celona microslicing. Now let's look at the Celona AerFlex capability of local breakout. In edge-based deployments, the access point creates an encrypted tunnel with the edge. For Celona AerFlex, splitting up the Celona edge services into the access point and cloud would result in poor performance if we had to turn around data with the Celona cloud controller. Here, we can see pings from this laptop to the Google DNS server on the internet, versus pings from the Zebra TC78 on AerFlex to this laptop. The pings to the laptop are faster, even through the analog to digital conversion of private cellular, because for the first time in the private cellular industry, Celona AerFlex is able to route user traffic straight to or from the access point and the local server. With good connectivity verified, let's look at how we can apply quality of service for guaranteed performance with Celona microslicing. Let's start with no traffic on the network, with pings to the Google DNS server at IP address 8.8.8.8 from both devices. Let's add some traffic. We'll run iPerf from the Zebra TC78 to this laptop. Okay so far. Now let's do the same with the ET45. Again, running iPerf to a different port to this laptop. Right away, we can see that the TC78 pings, even to the same server, are increasing in response times, while the ET45 keeps the ping times nice and relatively low. In this setup, we configured Celona microslicing for devices matching a specific device profile to prioritize traffic to our application, which we defined as the IP address of the Google DNS server. We could also filter by server port, DSCP bits, and source ports. In the microslices page, we configured a microslice to prioritize this application for all devices with IoT device profile and set the priority to highest priority signaling. A microslice could also be configured for guaranteed and maximum bit rates for the application. Thank you for learning about Celona AerFlex. By removing the need for an edge server on site, Celona AerFlex is democratizing private cellular for all sites, big and small.